Hello everybody, we are going to talk about chapter 1.1. We are going to talk about function and change. This is the first section of the calculus, and before we do, I'd like you to review the graphs one more time. So let's look at those 8 graphs that we have learned in pre-calc class. Also, I made those t-tables. So let's plug in points, and then one by one let's see the shape of the graph, and then let's remember the name of the equations. So this one, if I plug in those 5 numbers, it's going to be 2, 1, 0, -1, -2. So the points that I'm going to have is going to be these. So therefore, my graph shape will be linear. Next one, by plugging those 5 points, I'm going to have those 5 points again. And carefully plotting the points, I'm going to have parabola. Next one is the exponential function. Since you guys know we are in COVID, and that is the exponential function. So I'm going to plug in these numbers and carefully, I know that 2 to the 0's power will be 1, -1 will be 1 over 2, then 1 over 4. So I remember that those negative numbers become negative number becomes the exponent with fraction numbers. And log, as long as you have your exponential function, these are the inverse to each other, then you can use the same coordinate switching x and y. Therefore, 4 to be 2, 2 to be 1, 1 to be 0, 0. I want you to remember that actually there's no 0 exist, do not exist, and then also log do not have negative numbers. So we only get those values. That's the graph. And next one, absolute value. By plugging those 5 coordinates, same idea. I'm going to go a little bit fast. I'm pretty sure you can plug in. Also, you can use a calculator. So I'm gonna get the V shape. It's not a really nice V shape. And square root, you also plug in the t-table that I given to you. That will do square root of 4 is 2, square root of 1 is 1, and 0. But remember that this one do not have negative. Also, these two are inverse to each other. And the rational function is going to plug in 7, 8 numbers that you see here. So plug in carefully. By 2, it's going to be half, 1, 2, and then other side as an odd function. This is going to be this format. However, remember that we also have an asymptote. And last one is the equation. It's not a function. Also, it's a circle, which is the same as a Pythagorean theorem. Then your distance is going to be 3 all over from this center 0, 0. So I want you to notice center 0, 0, and then radius as a 3. Then I can graph this circle. So I want you to remember all those 9 graphs, and these are the pre-cal and then algebra 2 practice. So we are going to continue 1.1 after the graph, and I divide into 3 different parts. It's going to be appetizer, main dish, and dessert. So appetizer will be the review of you have learned before, and then main dish will be our material, and then dessert will be a little bit of the challenge, and then some of the materials that I included your homework questions that it will be beneficial if you watch it. I will try to make short videos like 30 minutes so that it will be nice if you go over with the handout that I uploaded it, and then try to see 1 week that it be helpful for you, and then give me feedback. Okay, so let's look at appetizer 1.1, which will be the review. And let's talk about if you remember any linear model for our life. So although you are not aware of it in our life, we are actually in a lot of linear models. There will be a lot in around of us. And for example, if we pay tuition per credit, let's say that in California it's about $50 per hour. So if you take 10 credits, it's going to be $50 times 10. So it will make about $500. Also, you can also talk about your wage. If you work right now and $15 per hour of your wage, then if you work 10 hours per week, then that will give you $100.50. That is the linear model. So if you think about it, actually there are a lot of times that we are using it, especially in grocery stores. We use it a lot of times, but we're probably not aware of it. So if you understand about the linear models, let's see that what does a slope means. Everybody know that slope is rise over run. Also, we have a formula of y1 minus y2 and x1 minus x2. Well, I put it backwards, but actually as long as you put it right order, it doesn't matter. So you can actually put this way. So rise over run is our slope, and then that is going to be our rate of change. And then when we're sending the rate of change to the limit x close to infinity or 0, we are going to see that, or at that certain point A, we are going to see that that actually become our derivative. Okay. So let's look at just a quick example from algebra class. I'm going to plot those points. 1, -2, and -4 and 3. So if you connect these two coordinates, sorry, I never make it straight, and you can find the slope. There are two ways you can do. You can count the rise part, which is going to be down 5, and then to the run 6. So this one I can say that my slope is it's going to be run 5. So it is going to be -5 over 5, slope is 1. Also, you can use this one as a formula. You can put it as y2 minus y1 over x2 minus x1. That will give you same answer, which is same as -1. Sorry, there was a little mistake. So whenever it's a points that outside of the coordinates, probably it's easier to use a formula. So I will just use a straightforward. -5 minus 2 over 12 minus -8. So that will give me 7 over 20. That will be my slope. Okay. So let's continue. I like to graph this one. If you graph this, -3, 4, and then 2, 4, I get to see that it's horizontal. What is the slope? When you have a horizontal line, slope will be 0. Just think about the angle. Angle is a 0. But if you don't trust me, just plug into the formula again. Then you're gonna get 0 over 5, which is 0. Then think about D. I'm going to graph this one, and that is going to be 3, 2, 3, -4. I want you to think about for a second. While with the slope, when we have a vertical line, when we have a vertical line, think about this way. We cannot walk. So we say no slope, undefined. Also, if you plug in this one into formula, -4 minus 2 over 3 minus 3, that gives me -6 over 0. We know that this is undefined. So always remember the horizontal line, it has a slope, which is 0. Vertical line, slope do not exist because you cannot walk. Okay. So if you had a review about the linear equation, look at the example of the data which I showed here. This is the population of two places, and there are P and Q by 10 years. They check the population. And I want you to look at the pattern and which one represents the linear or which one represents the exponential function. When you look at the first one, I see the pattern that here to here, each time it multiplies by 3. And if you look at the population Q, each time population added by 30. I want you to see the differences between these two. One of them is exponential, one of them is linear. So when the population multiplies, this is going to be exponential function, and this is going to be linear function. So now, since I found the population linear model is represented by function Q, then I want to find the equation. Equation format of the linear function is mx plus b. So I want to see that by slope, Q is the linear equation increased by 30 as a population over 10 years. Careful, it's not 1 year. If it was a 1 year, you can just put it 30x plus 400. But it's every 10 years that I'm gonna divide by x value by 10. Then population of Q starting from 400, my equation is going to be, oh, I forgot x, 3x plus 400. If I want to find the equation of the exponential model, it's going to be p function. Exponential function has model of ab to the x. So careful, a is the starting number. So in this case, it's going to be 100. B is the growth factor. And this time multiplies by 3 and then over 10 years. So if it was over 1 year, it's going to be x. But since over 10 years, every 10 years is going to be tripled. So my equation is going to be this. So after that, I actually have in-class activities. The problems that are very similar to what I just did. So I'm going to give you a couple of minutes and then try your in-class activities. If you get a chance, did you get to finish in-class activities? Let's compare the answers together. So here's a linear model and exponential model. This one is added by 50 each 10 years, and this one is times by 2 each 10 years. So I can tell that P is the linear model and equation is y is equal to 50 over every 10 years x plus starting number 200. So 5x plus 200. And then exponential function is population Q and y is equal to starting number 200 and then times by 2 x over every 10 years. I hope that you got the right answer. If you got it, good job. And keep playing with me. Okay, so I'm going to start now main dish. And this chapter 1 is actually easier than what you think because these are all the review of your pre-cal. So when we get a chance, just I want to review thoroughly with me, and then I will go over some of the reviews part to explain for you. So what is a slope? Slope is rate of change. Whatever it changes, you can actually think about slope. Like my hair is growing, my fingernails are growing, my height is growing when we are a teenager, and then maybe your weight is growing. So these are all we can say as a slope. And in mathematics, we are going to define by m, which is delta y over delta x, changes in y's over changes in x. Then what is a function? Function means input, then you must have one output. A lot of times you guys using on internet, and all of your internet, they're gonna ask you one login name and one password, and that will be all the functions. Also, your social security number is a function. If you are at Skyline students, you have a G numbers, that's also function as well, because you only get one output per student. But what is not a function? If you can think about, if I want to go to San Francisco, you have a way to take a Uber, bus, BART, or car. So you have 4 different choices. Since it's not one way to get there, it is not a function. So only function has a one output. So remember that. And then what is a domain? Domain means all x values. And then range means all y values. You can think about this way. Sometimes people do not think about domain is important, but when you drive, you don't want 5 years old kid want to drive, right? So that time driving age will be 16 and a half, I'm not sure, 15 and a half through probably, I will say it's 100. So those will be your domain. And then range will be the value of the outcome correspond to your input of the domain. So in here, we are going to quickly review 2 major equations. Slope-intercept form of a linear equation, other one is a point-slope form. If you forgot about when we use this one, just look at this explanation, you will understand totally. So there are 2 equations, which is a slope-intercept form we use when you know slope and intercept. The form is mx plus b. Point-slope form is you're gonna use when you know the point and slope. But all the time, actually you can use point-slope form, it will work 100%, but it will be just a faster use slope-intercept form if b is the y-intercept. So let's look at the example. So find the slope-intercept form of the line passing through the point 0, -1 and slope 2/3. This equation, I have point and slope, then you can actually use point-slope form. However, I found this point to be y-intercept, so I can just directly plug in 2/3x minus 1. Why? Because this is the point, but also y-intercept. How do I know that's y-intercept? Y-intercept means x is 0. And point-slope form is when you know the one point, we are going to have still y is equal to mx. Then if you know the point, you are going to plug in that point in the equation. Actually, if you isolate by m, then it becomes slope equation. So that's how related here. So I want to show you with this one if I can use a point-slope form. So I have a y minus y1 equals m and x minus x1. Plug in previous example, I can plug in y minus -1 and then slope 2/3 x minus 0. If you solve this one carefully, you will get y is equal to 2/3x and then -1, which will be same as the previous answer. So as I mentioned, you can actually use point-slope form for any time. Then let's look at example 3. Then if you understand when we use a point-slope form, you are going to plug in a point given and then slope given there. So look at the example 3. I want to find the point-slope form that passing through the point -2, 3 and then slope -4. So I'm going to plug in carefully y minus 3 equals 4 times x minus parenthesis 2. If you organize, it's going to be my slope-intercept form. So it is going to be 4x plus 8 plus 3. That makes 4x plus 11. That is your slope, point slope form. So think about, what do we need in order to graph? If I want to graph, you need to have 2 points. Or if you have slope and 1 point, you will get to graph it. Or how many points do we need? At least we need, again, 2 points. That's all you need. If you find 2 points, you get to find the equations. Make sure that you can always use point slope form. Now it's waiting for your in-class activities. There are 3 questions, 1, 2, 3. Please pause your video and see that if you can do next 3 questions and then compare the answer with me. Okay, so I want to check the answers of in-class activities 1, 2, 3. And if you got the right answer, good job. And if you not, just keep trying and then find your mistake with looking at my work. And make sure that you also print it out and then so we are going to start the dessert part. And that is going to be a little bit slightly more challenge, but this material actually, as I mentioned, chapter 1 is a review. I hope that we recall and then refresh all those memories. So example 4 of the dessert. We want to see that when you look at the system of equations, if those equations represents a parallel, perpendicular, or neither. As soon as you see this one, that means that they're asking about slope. So let's try to find the slope for A. So when you look at the slope, slope means we isolate by y. So in first equation, I'm going to isolate by y. I know that 2y is equal to negative x plus 7. Divided by 2 makes negative 1 over 2x plus 7 over 2. So slope is negative 1 over 2 for first equation. And then let's look at second equation carefully. If I isolate by y and written as mx plus b, I get to see my slope. So in this case, I move the negative 2x to the right side and I see that slope is 2. So I have one slope, negative 1 over 2, other slope is 2. The relationship in this case is going to be perpendicular. So it's a perpendicular. So now let's look at another example. we can rewrite this one as y again. But as you see, this time I have a negative y, so I'm going to move y to the right side. Then I don't have to touch much. So my first equation becomes 3x minus 4 equals y, since I move y to other side. You can do that for the second equation. Because that's negative, I don't want to divide by negative, so I'm going to leave 6x plus 12 and instead moving 2y to the right side. Then I need to rewritten as mx plus b, so let's divide by 2. That will be 3x plus 6 is equal to y. So if you want to find the slope, first one has a slope 3, second one has a slope 3, both has a slope 3. This will be the case of perpendicular. Now, I want to pause the video and then work on in-class activities C. I will wait for you. Try to do that and check the answer with me. Okay, I hope that you had enough time to do the C of in-class activities. If you compare the answer, I got negative 4 with 3, and then second equation I got 2 as a slope. So this case is going to be neither. I hope that you got correct answer. Okay, so let's review some proportionality. If you think about y is directly proportional to x, it has a linear equation. Y is equal to x. But we also have to use constant of proportionality, which is a k. So you can think as y is equal to mx. If variation has inverse relationship, we say y is very proportional to x. Y inversely proportional to x. Then you are going to write it inverse way. Y is equal to something over x. Because it's an inverse relationship, then you are going to put also constant proportionality k. If you want to review the variations, you can actually check page number 8 of number 27 through 31. Okay, so now we are going to have now today's highlight dessert. Example 5 is also from your textbook example, and then find the coordinate C of the given equation. So I want to think about what I need to do. We have a quadratic equation which I can see that y is equal to x squared. Then I have a linear equation, they didn't give it to me what equation is, but since I can use a slope and point, I can find the equation of this line. So let's try to do that. If you look at here, I want to see that you see slope is down 1 and then over 1. So m is negative 1. And then luckily I have a y-intercept, which is 2. So using this information, I see that the equation of given straight line will be negative x plus 2. So I have these two equations, and I know that these are meeting at given 2 points. So if you guys remember system of equations, this time I can use actually substitution, because these two coordinates of x will be the same value. So I'm going to connect these two equations the same. Basically, I'm saying that x squared is the same as y, which from this equation, but that is the same as negative x plus 2 came from second equation. And we see that those x, y coordinates has to be the same. So deleting this y part, we get to see all I need to solve is this equation. So let's see if it factors. I see that if vectors as x minus 1, x plus 2, I'm sure you guessed that too. So from here, x is 1, x is negative 2. I got x is 1. If I plug into my original equation, I will get 1.1, which is this coordinate, which I already have. So it should be negative 2, which corresponding to the c value. So if I plug in negative 2 into the equation, it doesn't matter which one you plug in, then that will give me x squared, which is negative 2 squared. I get the coordinate, which will be negative 2, 4. So the coordinate of given function intersects these two equations will be negative 2, 4. There will be similar questions, so I want to try. And thank you for following the video for today, and hope that it was enjoyable. Keep playing. Math is like a video game. You will get better.